Yeah, good morning. I'm going to take the foundations of artificial intelligence. So, this foundations of artificial intelligence, it is a module of knowledge, reasoning, and planning. More, it is module of knowledge, reasoning, and planning. So here, knowledge representation (KR). So the knowledge representation, knowledge reasoning. Okay, KRR, knowledge representation and reasoning, KRR. This term is very familiar in artificial intelligence. Humans are very good at acquiring new informations by combining raw knowledge, experience with reasoning, and the knowledge is a power. It is an AI slogan. Knowledge is a power, or data is a power. Okay, so any medical data, any knowledge related to the medical, so that is an AI slogan. Some of the websites, it is expressly available by some datas. Example, medical diagnosis. Physician diagnosing a patient infers what disease based on the knowledge she acquired as a student, textbook, and prior classes. Okay, so common sense knowledge, the reasoning, common everyday assumption, and inference. Say example, lecture starts at 4 inter PM, not AM. So when traveling, I assume that is some way to get from the airport to the hotel. Okay, so these are only examples. Knowledge K or knowledge representation, K or knowledge representation and reasoning. Some way you will get raw knowledge, some way you will get experience with reasoning. Okay, you say your life as example, so you can get some representation, some reasonings. Okay, next one is logical agent. So knowledge KRR only will comes under logical agents. The agents with some representations of the complex knowledge about the world, its environment, and use inference to derive new informations from the knowledge combined with new input via perception. So here already I told representation of the knowledge in what form, meaning slash semantic, reasoning and inference process efficiently. The key issues is two issues in the logical agents. Okay, so it is based on some representations of the complex knowledge about the world. Okay, maybe the representations of knowledge, some standard format, some meanings, or semantic format. Okay, so and uses inference to derive new informations from the knowledge combined with new inputs. Okay, so every time you will get data, some data, new data, so the combined with the new input. Okay, that exactly via perception only, new input, that is exactly via perception only. So that two key issues, don't forget in logical agents. Knowledge based agents, knowledge, it is a key issues is representations of knowledge base, reasoning processes, inference slash reasoning. Okay, reasoning process means inference, reasoning slash reasoning. The knowledge base equal to set of sentence in a formal language representing fact about the world. Okay, knowledge base means set of sentence in a formal language representing facts about the world. So that is called it is called knowledge representation, KR language, knowledge representation language. Then knowledge bases. Key aspects of the knowledge bases: how to add sentence to the knowledge base and how to query the knowledge base. So both tasks may be involve inference. So that is how to derive new sentence from the old sentence. Okay. So this both task involves how to add a sentence to the knowledge base, how to query the knowledge base. Okay. You have to derive new sentence from old sentence. Logical agents means what is exactly logical agents? Here, inference must obey the fundamental requirement that when one asks a questions to the knowledge base, the answer should follow from what has been told to the knowledge base previously. So, in other words, the inference process should not make thing up. Okay, inference engine. So two things are there in logical agents: inference engine and knowledge base. Inference engine means domain independent algorithm. Knowledge base means domain specific content. Knowledge base means here previous slide also knowledge base we discussed. So in knowledge base means that is exactly representations of the knowledge, that is the key issues, that is the knowledge base. So another exact meaning knowledge base: set of sentence in formal language representing fact about the world, representing that particular sentence, set of sentence, formal language representations, uh, it representing the fact about the world. It is a knowledge representation language. So that is a specific content, domain specific content. Inference engine means independent algorithm. Okay, inference engine means independent algorithm. So here inference, we are telling inference must obey the fundamental requirement that when one asks a questions to knowledge base, inference engine is different, inference is different. So the logical agents, inference must obey the fundamental requirements that when one asks the questions to knowledge base, the answer should follow from what has been told to the knowledge base previously. So same thing will reply in this answer. Sample knowledge based, it is a small pseudocode for the sample knowledge based agents. Sample knowledge based agents function: knowledge base agent, return an action, static knowledge base, comma, a knowledge base, t, a counter, initially 0 indicate time. So here you see the make percept sentence, percept comma d, kp. Okay, action no, ask kp, make action query of t. Tell no, kp comma make action sentence of action comma t. T implies t plus 1, return action. So this time mid-semester exam also ask about the that is PEL ASK. Two things asked. It is an you have to tell about the simple knowledge based agent. Okay, so that tell KP make percept sentence of percept comma T. Tell no KP comma make action sentence action comma T, percept comma T, action comma T. You explain no, will get full mark. Then agent must be able to represent state action, incorporate new precepts, update internal representations of the world, and deduce hidden properties of the world, deduce appropriate action. Okay, that only. So it is an exact meaning of this only. So it represents each and every representations of state and actions is given first two line, and incorporate new precepts, that is the precepts comma t, incorporate. Then next one is update internal representation of the world, action, ask. Okay, kp comma make action query of t, deduce hidden properties of the world. Okay, so that is tell, deduce the appropriate action. Appropriate action, tel, deduce kp comma make action sentence of action comma t. So that is the exact meaning. This once this you write it in answer, no, you will get full mark. Care language. Language is propositional slash first order combined with logical inference mechanism. How close to the human thoughts and mental mode and John Lyd. What is the language thought? Craig uh, or Hindi or Kannada, regional thoughts logic. Why not use natural language? So we went clearly syntax and semantic and mechanism to infer new information. Solution is use formal language only. Okay, so why not use natural language? Example English. So clearly the syntax and semantic well defined meaning. Okay, so the next one is representation language. Here expressive and conscious and unambiguous and independent of the context, and have a effective procedure to derive new information. Not easy to meet this goal, and propositional and first order logic meet some of the criteria in completeness and uncertainty is key and contrast with programming language. Decent representation of language. Okay, the intelligent system design, agent and intelligent system 1943, the natural explanations is this one. Small scale model, it is old information, action within its head, and various alternatives, and conclude best react of the futures and situations before arise. Okay, the present and future, no, fast event in dealing with present and future. So they every way they react in much fuller and safer and more competent every way to react in a much fuller. It is an against representation. Here procedural style, print color, right, it is a white. Okay, snow is in white. Then print color, grass. So the white it's green. Okay, print color, sky, right, it's blue. So print color X, right, beats me. X means unknown. Knowledge alternatives. The print color X comma Y, right, it is right Y. Y, right, maybe snow. So the color, so snow, color grass, color sky. It is a KP. Knowledge base. It is a knowledge base. Knowledge base alternative is This is an example for knowledge base alternative. Okay, so don't forget, so in 3 color is given. Okay, so that color also specifically written. One color it is specifically X, so maybe color XY. So write X it is, write Y, write. Okay, these 3 colors, so it is KB, knowledge base. Logical representation. Logical representation, 3 components: syntax, semantic, proof of theory. 3 representations. To make it work, soundness and completeness. Okay, 3 component of logical representation: syntax, semantics and proof of theory. The connecting sentence to the world. Connecting sentence to the world. Here representation world. The sentences here sentence. Entailed sentence. Here to semantic it is below arrow mark. Fact, this is here also fact. Here entails, here follows. Okay, so it is the one of the sentence to the world, connecting one of the sentence to the world. Representation world, center point. Okay, dotted lines. Sentences, sentence entails. Fact, facts, fact follows. Both it is semantic only. Fact, semantic, facts, here fact. So here somewhat misleading formal semantic brings sentence down only to the primitive components. Proportion. Okay, later. So somewhat misleading. So the formal semantic. So semantic is there. Semantic, 2 semantics are there, that crossed down arrow line. Okay, so that formal semantic brings sentence down only to the primitive component. So proposition, that is proposition. And dangerous link to the real world. Dangerous link to the professional world. Here it is world. Okay, here not, it is a user input sentence to another without system. No, maybe it is an agent. Computer has our sentence. All computers has our sentence. Hopefully about the world, the sensor can provide some grounding. Hope knowledge base unique model and interpretations, the real world often many more. Aside, consider arithmetic a simple grounding problem. Here computer has or sentence hopefully about the world, and sensor can provide some grounding. Okay, hope KP knowledge base unique model / interpretations, the real world often many more. Consider arithmetic, that is aside consider arithmetic, the simple grounding problem. It is called simple grounding problem. So it is a link to the real tenders, link to the real world. More concrete, here and or, so here the sentence from atomic proposition using connectives and or not implies means bidirectional, then equivalence means unidirectional. So implies means unidirectional, equivalence means bidirectional, biconditional. Okay, it is an example is given, not P or Q and R implies yes. It is an one of the propositional logic. Propositional logic. Example. So you can give some 1 or 0 to the P or some input Q or you will get yes. Okay, it is a built-in sentence atomic proposition using connectives and or not unidirectional and bidirectional. Implies equivalence. Here it is an one example for the semantic. Here false some uh, counterintuitive. Okay, so note some counterintuitive P and Q values given. Not means it is opposite to P. Here false, false, true, true is given. Then true to false. P and Q. P and Q means false, false means false. False, true also false. True, false also false. True, true is true. P and Q. P or Q means false, false only false, remaining everything true. P implies Q. P implies Q no. Only true, false is false, remaining all true. Then P implies P equivalence. Equivalence means false, false means true, true, true means true, remaining false. Here, what we are going to, what is the truth values of phi is even implies same is smart. Somewhat counternative. Validity in reference. Here, truth table for premises implies conclusion. So, P or H. So, here it is a different value. P or H and not H. Okay. So, implies P is valid. All true. Okay. So, the same way in previous table, the truth table, the true is all interpretations. We write P and P or H. P or H means only false, false is false, remaining all true. Okay, and then not H. Then P or H and not H. Not H means only true, remaining all false. Okay, so that you are going to and know. All true. Okay, so that's all for the validation interference. Here models. Here it is one model of set of sentence KP is there, which each of the KP sentences, so which more and more sentence the more and more like real world. So if a sentence alpha hold is true in all models of the KP, so we say that alpha is entailed by KP. Alpha is of interest because whenever KP is true, so is a word, so alpha will also be true. So the KP define exactly the set of word we are interested in will also be true. KP equal to alpha. It is in real world. So here some examples is given inside, outside. So M of alpha, MKP, KP, this all MKP. Okay, outside M of alpha. So M means module. Inside also some separate module. So the model KP, the model alpha. Proof of theory. proof of theory purely syntactic rules for deriving logical consequence. C, a set of sentence, and we write kp alpha, that is a can be deduced from kp, or alpha is provable from kp. So the key property, both propositional and first order logic, we have proof theory, calculus, such as the and equal to or equivalent. So that simple, it is in proof theory simple. Key properties. Proof theory, alpha implies kp equal to alpha, we say proof theory is sound. Implies kp minus alpha, we say proof of theory is complete. Why so remarkable slash important? Which one is important? Which one is remarkable? The soundness and completeness allow computer to ignore the semantic and just push symbol. So the propositional logic truth table comparison, at least the first order model can be infinite. Proof theory, so one or more inference rules with zero or more axiom, that is tautology, to get things going. Okay, so this based on purely on from of statement, not on the meaning of the individual propositions. Here the propositional logic truth table cumbersome, at least in first order model can be infinite. Example of proof theory. So here one rule inference, it doesn't modens ponians. So from alpha, and alpha implies beta, that follows that beta. The semantic sounds easily verified, truth table. So axiom 1, axiom 2, axiom 3. Axiom 1, alpha implies beta implies alpha. Alpha implies beta implies gamma. Okay, so alpha implies beta implies alpha implies association rules. Axiom 3, not alpha implies beta implies not alpha implies not beta implies alpha. Note that alpha, beta, gamma are the arbitrary sentence. So the infinite collections of the axiom is different. So these three example axiom schema. The reduced set of sentence by so the sequence of the applications moderns on, so that lead from pi to alpha, possibly using the axiom. Prove that modern proponents, so with the above axiom, will generate the exactly all the statement logic entailed by beta by pi. So this generating the entailed statement in the purely syntactic manner. This is again axiom, same thing, and lemma. So lemma, any alpha we have, alpha implies alpha. Alpha implies alpha implies alpha implies alpha implies alpha implies all. Finally, alpha implies alpha. It is axiom 2. Axiom 1, alpha implies alpha implies alpha implies alpha. That is axiom 1. 3, alpha implies 2, alpha implies, that is MP. 3, continuous three continuous alpha implies, so that is axiom 1. So the logical agent perspective, we take the knowledge based approach, and knowledge based in inference procedure to derive information. The representations has well defined syntax and semantic meaning. How far the system in the knowledge reasoning paradigm. So here IBM, so playing system, Jeopardy playing systems. It is one of the example, basic layout of the Jeopardy game. It is also based on the AI. Key aspect, limit of number, category of type of questions, well-defined knowledge sources, then around 70 expert model that handle different aspects of the possible questions and answers, final results based on the confidence vote, limited language processing, uh, lot based on individual word, and IR parsing, limited knowledge graph, and book have other, movie has actor, director, verb represents an action, etc. Some games theory, two reasons about whether to answer. Some extent Watson understand. Actually, bit of problem for IBM. Client expect too much. It is one, especially one game data. Okay, so semantic web. Semantic web means data government process the converting CSV data into resource description frame, RPI, tetherless word consolation, and then RDF triple fact class and subclasses, OWL define class constraints, and direct grow out KR work in AAA community 1985 to 2005. Ron Brochman. The many others is that France border and Fernand and Peter Petal. Okay, Alex Borgida. Okay, so these are all different other directly grow out the KR working. So here see trust, proof, logic, okay, rules query, ontology, RDF model and syntax, XML query, XML schema. This all it is based on the encryption and signature, XML namespace, URI, IRI, Unicode. Then knowledge intensive. Robin knowledge verification, here machine learning, data intensive, and then inference search intensive, knowledge intensive, NLU common sense, computer vision. Okay, 20 plus year GAP, it is in Google Knowledge Graph, and semantic web, Watson Google, and then Google search IR. So this is then data interface triangle 2012 in AI. Illustrative example, Wumpus World. So Wumpus World, the performance measured gold 100, death 1,000, and filling into the pit or being earned by the Wumpus. So 1% step 10 of the using the arrow environment. So the room sequences connected by the door, and it isn't say for the environmental examples square adjustment, Wumpus or Somali, and then square adjustment to pit or breezy, and so likewise shooting kills worms if you are facting it, and shooting uses up the only arrow, and cropping picks up gold if the same square, and the releasing drop the gold in the same sequence randomly generated at start of game and warm up only since current room. So here uh, stints, breeze, glitter, bumps and scream. So here the room connected by the passive way, and so it is in game possibilities. Anyone who enter it room and warm can sort by an agent, and the agent has only one arrow. So some room contained bottomless pits. Okay. So this it is an the agent way to start it square 1 comma 1 facing to the right locations of the goal, and wa- wombus are chosen randomly with uniform distribution from the square other than the start sequences. Each sequences other than the start can be pit with probabilities. Warm up world characterization is, yes, no, yes, no, yes, no. So the static means deterministic means yes, then static means yes, warm up and pits do not move. Discrete S, then single agent S. Warm up is essentially natural feature. Fully observable, no, only local perception. It isn't character 6. One of the so exploring the warm of the world, Wombus world. Knowledge base of the agent and consists of rule of the Wombup, Wombus world, and plus and percepts nothing. Boolean perception features. Okay. Here all Wombus only. KPA agent consists of rules of the Wombus world plus inference the agent's knowledge based on also has the information that 2 comma 1 and 1 comma 2 okay add as pass proposition. Here full exploration of the Wombus. A means agent, V means visitor, B means brace, T means what follows, PAT 2 comma 2 or PAT 3 comma 1. All Wombus explanation only. So formally entailment, this one. Situations after deducting the nothing 1 comma 1. So only moving right brace 2 comma 1, that is T equal to 1. Here also 4 comma 1, 4 comma 2 only. Boolean choices, 8 possible interpretations. So the KP consists with all 8 possibilities. The world that violate KP. Entailment Wombus world. So the Wombus model. So this not required. It is not also in syllabus. One game, the model checking. Entailment of the model checking. No. So the KP model and check alpha 1 and alpha 2 are the true, and the model implies that it can be used its when we have finite number of model. So model KP, model of alpha. So it is all Bombus probabilities only. Okay. So this not required much. Okay. True or false, that proportional logic, that is enough for us. This all calculations only. It is not this required semantic. So already explained this particular one. Logical equivalence, all logical equivalence, commutative, associative, and double negation, elimination, and contrapositions, position, and implication elimination, mm, biconditional elimination, De Morgan law, distributive. So this also required some logical equivalence. Okay, so this not required that much length of rope. So only up to loss. Okay, so that's all in the second unit part of the topic. Okay, so remaining we'll discuss tomorrow. Okay, thank you.